There's a couple different ways to figure out the empirical formula given this information. One way is to determine the number of grams that of each element composed in the compound. Another way is to do it by percent. So this particular video is going to show you how to determine the grams of each and then determine the empirical formula. So we're going to start off with 40.10 grams of one sample of the compound. And I know that in that compound there is carbon, hydrogen, chlorine, and oxygen. So my goal is to determine the grams for each. And so we're going to start off by looking at what they give me. They give me 58.57 grams of CO2. Well, I know that whenever we have a compound that contains carbon being burned in oxygen, 100% of the carbon goes into CO2. So if I know my grams of carbon in the CO2, then that's my grams of carbon in the compound. So to figure out that, I'm just going to multiply by the fact that CO2 has 12 grams of carbon for every gram of CO2. That's just from the molar mass. And so when I calculate this out, I know that my CO2 is going to be gone. And so I'm going to have my grams of carbon. So when you work this through, you end up with 15.97 grams of carbon. So what I'm going to do is I'm going to kind of write that on top so I can kind of keep up with what I have. The next piece of information that they give me is that I have water. So I have 14.98 grams of water. So again, looking at the compound, I know that in water, if I look at the molar masses, there's 2 grams of hydrogen for every 18 grams of water. So when you work that out, 14.98 divided by 9, which is 2/18, I get 1.664 grams. Really don't worry about the significant digits because I know when I'm all done, I'm going to end up with a whole number for my empirical formula. So it's a good idea not to round too much because then your ratios may come off wrong. So then the next piece of information they give me is that I have another sample of this compound. And it lets me know that in that sample of 75 grams of that compound, that sample has 22.06 grams of chlorine. Well, to help me out on this particular one, I need the percentage. I need to know in this particular sample, in this particular compound, what percent is chlorine. Well, this is pretty simple because in another sample of the same compound, 22.06 grams of chlorine to the entire compound, which was 75 grams. And so I just figure out the percentage, and if you divide that out, you get 0.294. And so if I wanted to convert that to a percent, I could, but that's the fraction of chlorine in that compound. And so I need to take that, and I know that 0.294 of the total compound, which is 40.10 grams of our original compound, of our going back to the first sample, has got to be, that's the fraction of chlorine in this compound. And so if I multiply that out, I get the grams of chlorine, which comes out to be 11.79. So now I know my carbon, my hydrogen, and my chlorine, and I know that all of this has to add up to 40.10, but I don't know my oxygen. And so to find oxygen, very simply, I know that 15.97 plus 1.664 for hydrogen plus 11.79, if I add that all up plus whatever oxygen is going to equal 40.10. So I just add those 3 up and subtract it. And so when you do that, so if I take all of this, subtract that from 40.1, I end up with 10.68 grams of oxygen. So I know that this is 10.68 grams. So all of those together are going to equal 40.1. So then the next step then is, okay, I have all my grams. Now I move to a very simple empirical formula problem. So I'm just going to kind of rewrite my numbers so I can get this to work out very simply. So I'm going to kind of create my little empirical formula table now. So 15.97 grams of carbon, 1.664 grams of hydrogen, 11.79 grams of chlorine, and finally 10.68 grams of oxygen. So then my next step, so that's my given, and then we're going to do the empirical formula steps. And so the empirical formula steps are that I need to convert them to mole. So I'm going to go to moles. So to do that, I'm going to write down the molar mass. I've jumped back here. So I'm going to write down the molar mass. So I know carbon is 12, hydrogen is 1, chlorine is 35.45, and oxygen is 16, and I'm going to convert to moles. So then when I work that out, I know that my moles of each one of these guys is 1.33, 1.664, 0.333, and 0.6675. So my next step is to figure out that mole ratio. I want my mole ratio. So you divide by the smallest. So I decide who is the smallest of all of these guys. Well, my chlorine moles are the smallest. So I'm going to divide by the smallest to get one of them to be a 1. It's always picking that smallest guy. And divide everybody by him. Notice that we're doing something to everybody. So we divided by their molar mass to get their moles. We divide them all by the smallest. And so when you do that, this equals 4. So my mole ratio is going to be a 4. And this is going to equal 5. Obviously this is 1. And then this is 2. So then I'm going to stick them back on. And so my final answer is C4H5 Cl with a 1, which we don't write, O2. So that is the empirical formula given that information from the original problem.